You can type it in the chat or just unmute and ask. We covered everything on Monday and Tuesday for the in-person exam. Remember, that is on Friday. So on Friday, you'll come on here and during class hour, and you'll turn your computer on. Make sure your camera is on Friday, because I need to be able to watch as much as possible that you're not cheating. You are allowed formula sheets and your problems. So if you didn't come to class on Monday or Tuesday, I would watch the video and work all the problems out as we did them in class. So then you have those notes and you have all the formulas. This is, oops, let me share my screen. There we go. These are my notes to remember to write on the test, but this is on As You Learn. And it has all the formulas that you would need and the problems that are on there. There's 10 questions, 5 points each, 3 these. There's one problem like this first part, one like the second, like the bystander one, and then one of each of these. 10 problems. These should be very quick. They shouldn't take more than a minute. The same thing with these two. So then the ones that take a little longer, you have a lot of time for it. Now, I set the time for 1 hour and 15 because I figure an hour for the test. And then if you have issues with the internet trying to post it, but if you, for some reason, have to have more time than that, that's fine. Just stay on. Don't just turn your test in half done. Just send a message to me that I still need to work on it, and that way I know, and you're just keep working.
So everything from Monday and Tuesday's video will go over what we're going to be doing in the test.
Yep. Yeah, we did all of these problems Monday and Tuesday, and that's all you'll see on the in class. All
right. Sounds like a plan.
Yep. We also, if you weren't there on Tuesday, talked about some of the take-home portion. Definitely, we talked about number 2. The formulas for number 3. Formulas for number 3 are on page 200 and 201.
All right.
Any other questions? So this take-home portion is due Sunday night. And the in-class is this Friday during class. 10 questions on the in-class, 5 points each. These are 10 points each. And remember, if you have questions, send me a picture. A couple people were working on it yesterday and asking questions. So. Any questions? Any questions on, let's do this part first because it's, any questions on the in-class? So you'll want a calculator. You can use Desmos if you need to or want to. Does everyone know where the log is on Desmos if you need to use Desmos? No? Yes? Maybe?
I do.
Okay. Because it's not just write out like your calculator would be. I'm supposed to go over so much 2 and 3. For the log, you click down here to bring up your keypad, and then where function is, log is in here somewhere. Here it is, right here. So then you'd click log, and like the first one was 7/10, 7 divided by 10. And then here's your answer. So under function, there it is, calculus. Any questions on that? Two and three. Number 2. Last class we talked about it. It's kind of just a thought process, and it uses bystander and cascade. Because if you think about it, if you're sitting with a bunch of people and you have to vote for one of 2 candidates, and somebody starts voting for one candidate, say they voted for A, but you wanted B, but then the first 4 people say A now, and then you're thinking, wait a minute, if I say B, they're gonna think different of me. And so it's kind of like that pressure, peer pressure, if you want to say, that you should vote for that one. You feel funny voting for the one that you want, but maybe if you did vote for it, others would vote for that person also. But then the more people that keep voting for A, the other ones feel that they don't want to be looked at differently, and so they also vote for A. So it's just explaining that, and that's with everything. My son plays tennis, and they're picking a team captain, and if you just keep hearing one person's name, then you don't want the others to think, oh, you just don't like that person because you voted for somebody else. And so everyone ends up voting for the same person. So you just have to give an explanation how that could happen, and what I said would work. How could we do it differently? Anyone?
You could make like a survey and do it online, or write it down,
Yeah.
the answers.
So we could have a silent ballot, either a survey where it comes up on your phone and you put A or B, or we just write it on a piece of paper, fold it in half, put them all in a basket, and then just start counting them. So a silent vote or a silent ballot. Yep. Because then no one knows who's voting for who, and you're going to put the person you want down. And that's all it was. It was more of a logical question than a mathematical, but logic is in math. So I just thought it was kind of interesting to think about. And there used to be in the regular QR class, there was a whole chapter on different ways of voting. So I thought this was kind of a way to bring that in. Any questions on number 2? Number 3. Oh, I have it open to the page. Okay, so static reserve is non-renewable resource, the length of time it will last. So how long will it last if we keep consuming it at the same amount? Now, it's not using a rate, it's a rate, but it's the rate at the same units. And I'll show you when I go to the next page what that means. Exponential reserve has a percent with it. It's changing by a percent, so it's exponential. Notice the formula for static reserve is the amount that's there and then how much of the amount we use each year. Where this one uses those two values, but it also says the rate is increasing by a certain amount. So this one is not increasing by a certain amount. It's just we use 10,000 barrels of oil per year, and we have 50,000 barrels. So it's just dividing them. But here you're saying that we're using the 10,000 barrels, but then that rate is increasing by a certain percentage. So these are the two formulas. Let's see, I think they have a question here. Maybe not. Okay. Number 8. In 1865, the economist William Stanley Gibbons examined Britain's coal supply. He estimated that Britain's mineral coal supply was roughly 10 to the 11 tons. This is the total supply. And the annual consumption is 10 to the 8th. So that at a constant rate of consumption, the reserves would last 1,000 years. But he also noticed that it was increasing exponentially, the rate it was being used at 3.5%. Okay, now I'm gonna, oh, I should have made this smaller so you could see what I was writing, but I just wrote down the main parts of it. And this was coal. Okay. Static reserve is R over Q. Now the one on the homework, it has a value in front of the tens. I guess I will show you how to divide those after we do this one. But it's just your reserve divided by how much is being consumed. So it would be 10 to the 11 divided by 10 to the 8. When you're dividing, you just subtract exponents. Oops, 11, 9, 10, 11, that's a 3. And that's how we got 1,000. So, if we stay at the same, or they stay at the same rate of consumption, it will last 1,000 years. Exponential is the log, using this formula right here. 1 plus, and then we already found R over Q. It's 1,000 times the rate. This is our rate, but it needs to be a decimal, 0.035. Divided by the log 1 plus the rate. And then you would plug that into your calculator. Log. If it grows exponentially, they will run out in 3.38 years. Any questions on that? So this is similar to number 3.
Wait, so whenever you're for the static reserve, like whenever you're figuring that out, you just subtract the exponents, like you don't divide the
Okay.
main number.
That's what I was just gonna, the one on the test has a number in front. So if we had 5.2 times 10 to the 11th for our supply, and maybe we use 2 times 10 to the 5th. So on the one on the test, it has numbers in front. And I don't know why they just use this. But if it has a number in front, yes, you divide those. Now you could write it all out with all the zeros, or you can just divide these two and then subtract your exponents. So if we take 5.2 divided by 2, we have 2.6 times 10, and then you subtract your exponents. 11 minus 5 is 6. $2.6 million years. So whatever this one would be, it would last 2.6 million years. So that's pretty good. But yes, you would have to divide those two then. So on here, the 1.5 divided by the 3, and then subtract the exponents. Any questions on that one? Any other questions? I'm confused on 5. Okay. The population is above. The deer population is above the habitat's carrying capacity. Remember, carrying capacity is how much you can have in an area and still have it be sustainable so that whatever they are using will still regrow. They don't want to damage the habitat. This is also a time, and this was talking about in the winter. This is also a time when deer are in very poor condition and death due to malnutrition and starvation because they're above their carrying capacity. So there's not enough growth. And in the winter, there's not a lot of growth, at least in our area to begin with. And then if it's overpopulation, it's even worse. Forest ecologists recommend that white-tailed deer populations in northeast hardwood forests should not exceed 20 deer per square mile. So we're allowed 20 deer per square mile. Mill Creek Park has 4,859 acres. So we need to find out how many deer they can have then in the park, what their carrying capacity is. How can we find that? Anyone?
Well, we'd need to put like the acres and the square miles into the same units first to
Very good.
solve
Yeah.
it.
So we could take, I like to always go, well, I went with acres. I thought it was easier to go acres to square miles and square miles to deer. Did anyone look up? 1 square mile is how many acres? Anyone?
It's 0.0016 square
Stick-
miles equals 1 acre.
Okay. Or 1 square mile is 640 acres, but yours should still come out with the same answer. What was it?
It was like 0.0016.
0.0016. I saw that and then I decided to go the other way because of the small decimal. But we'll do both. It should come out pretty much the same. The second one might be a little off, where this one's not rounding, but both will give us the same answers. So this one, acres cancels in both of them. And then we can use 20 deer per square mile for our other proportion. Would we put deer on top or bottom?
On top.
Right, because we want the 1 square mile to cancel. Now, you wouldn't do both of these, you would do one or the other. It's just depending on which one you've used. This would tell us how many deer the park could have. And I got like 151, 152, depending on rounding. Are you getting about 151, 152?
Yeah.
Now notice going the other way with this rounding, it's a little bit larger. I mean, it's not that many deer, but still. So I would look for an answer somewhere between 150 and 160 for your answer.
Okay, thank you.
But always show your work. That means the deer carrying capacity. I wanted to look this up because we live next to the park, and in the last year, we've had several deer in our yards. They eat all my flowers. But anyways, and that's probably why, because there's 3,000 deer last time they counted last year in Mill Creek Park, approximately. So the deer carrying capacity is 150 to 160 deer. Now, if they were checking this, what they would do is go with the low one, because you want to make sure that everything can be keep growing. But somewhere in there, and that would be part A. Part B is just, there's approximately 3,000 deer in Mill Creek Park. Do they need to worry about it? So this is just your opinion. You do the research, which tells you there should be 150 to 160 deer in the entire park. And then you would look at what there was, and you'd write to whoever you would need to, the park or newspaper. Any questions on part B? So the park has 3,000. You just need to explain if they need to worry and why they should. Any questions on that? Any other ones? Number. I gave this last class, but time to peak. The time to peak formula is log C over M minus 1. C is the total amount and M is how much was used. Any questions on that? Remember to find a certain section in your book. At the very bottom, it has, whoops, it has index. There we go. And most of the words you can find here, exponential and static reserve is there. Time to peak. I think it's here. Time step. Oh, maybe it's not. I thought it was on in there. Well, most of them are there. Hmm. I didn't put what page it was on. But this is the formula. Does everyone know what the time to peak means? So the two reserves tell you when you're going to run out. Time to peak tells you when it will extract the most. So coal keeps being extracted at an exponential rate of, what do we say? 3.5%. The time to peak will tell you when it has extracted the most. Because when you're talking about a certain percentage, eventually it's going to start going down again because you're going to start running out. So it's not when you run out, it's when you've extracted the most that you're going to extract. Before and after is below it. So it's those high points where once you hit that, you're going to start extracting less. Any questions on that?
So it's like the halfway point, right? Is whenever it's at its like highest production, or
Yes,
it's not
it can be.
production.
Sometimes it's like you have your peak and it goes down, and then things start getting healthy again. Like if you were talking about a forest and you hit your high point of cutting down all the trees that you were going to cut down, but then you plant more and they start growing. So it may drop, and then there might be another peak that's even higher. So as time goes on, there can be more than one. So it's not necessarily the halfway. It's just that for some reason, resources got low and it dropped, but then they build up again and it can go. But some things like oil, once it hits that high point, unless we find another spot, it's not making more. So then it is more at a middle. So usually, yes, it's at the middle, but some things can regrow, like forests, if you plant trees. So then when they go to cut them down again, you could hit another peak.
Oh, okay.
Yes. So for number 4, so let's keep the formula first. The US cumulative oil production was, yeah, because that's how much we took. So this is your M, and then C is the 200 billion. And again, when you divide those, like C over M, I think they're both billions. Yeah, they're both in billion barrels. You don't have to put all those zeros into your problem. Because they're both billions and barrels, it's just 200 over 40, they cancel. 0, so this is just 5 minus 1. So when they're the same units, they can cancel. Thank you. Time to peak is on page 217. I think they show a graph if let's see if it, oh, they're only showing the points right now. Somewhere there's a graph where it shows the peaks going up and then dropping and then going up. And here's the formula. So M is the amount that was extracted to date, and on our problem, it was 40 billion. Yeah. Thank you. On page 219 is the peaks. And you can see like this right here is a peak, but there's a higher peak. But depending on what year we're talking about, if it's only 1980, then this was our highest peak. Where you could see though, we had other peaks, in the blue is the deep water. The US is down here. We've stayed, compared to other areas, pretty steady because we know we need to reserve, but it could also be that we just don't have as many oil as other areas. But yeah, see how this blue, there is more than one peak, but this is the highest one since, well, we're in 2020, and then they're estimating 2050 that this is going to be the highest, then it keeps going down. Any questions on that? So the peak is telling you where there is a high value. It's not always going to be the highest, because in later years there may be more. And that's why it's not necessarily the halfway. Yes, the R has to be written as a decimal, and so it would be the 0.07. So the R in the formula, number 4 was 7%. So 0.07. One person turned the exam in already, but if you're seeing something you did wrong and you want to correct it, that's fine. It may not let you attach it again. Just send me it, email me it. Any other questions?
So would you take your answer for number 4 and add it to 1950 because it's asking what year?
Did it say what year, or did it say how many years? Yes. So if you should get, or no, I don't want to say. What are we getting? Did anyone calculate it yet? How many years are you getting?
I got 20.49, so it was like about 20.
Or 20.5, but somewhere like that, any one of these. Now that's the number of years, not the year. So if we wanted the year, we would, yes, add that to 1950. Any questions on that?
Wait, so we're like calculating the year, not like the number of barrels?
When would the time to peak formula predict the US peak production would occur? You're finding the time. Time to peak is a time. And in this case, it's years, and we're getting 20 years, which would be 20 years from 1950 would be 1970. So 20 years from 1950 or in 1970 is when we would have our peak. That means they will consume the most amount of oil in 1970. More than before and more than after.
Oh, okay.
Any other questions? Okay, that was it. Was there any other questions? Okay, if you do not have any questions, I will see you on Friday. When you're studying, if you have questions, text me, email me. If you're working on the take home now and you have a question, you could come into the office hour. And I can help you.
When will this Zoom be uploaded? Because I did miss one of the questions that we were going over, but I know you already did it, so I can just go back and look at the recording.
Okay, it takes me about 20 minutes to get it downloaded. But I'll do it right now because with the office hour and everything.
Okay, thank you.
You're welcome.